It goes to the left. It goes like this. So that's y equals the square root of x and the square root of negative x. And it's for x less than 0. So what should I actually have right at the origin that I don't have currently? What should I have there? There should be an open dot, right? There should be a little open dot right there. So right now we have an open dot. Good. Next function is 3 minus x. What's the slope of that line? What's the slope of this line? -1. Yeah, where does it cross the y-axis? 3. So you start at 3 and you've got a slope of -1. It goes from 0 to 3. And does it contain 0? Yeah, it does contain 0. So it's here, but it doesn't go there, and then you connect it.
Oh, so it's an open dot for 0?
Yes, because it's not equal to 0 right there.
Oh.
Okay. Look what it says right here, everybody. It's strictly less than. So does it contain 0? No. It's strictly less than 3. So does it contain 3? No. Y equals x minus 3 squared. So that's a parabola facing up. Parabola facing up. Where's the vertex of that parabola? At 3, 0, right? At 3, 0. So this thing goes like this and like this. So does it contain that? No, it's an open dot right at 3, right? So this is y equals x minus 3 squared for x greater than 3. And this is y equals x minus 3 for x, what was it? It was less than 3 and greater than or equal to 0. There it is, right there. Now, do we fill in this dot right there? Does that dot get filled in? No, it does not get filled in. So it says evaluate the limits. So does anybody have the 6 limits? Anybody want to rattle them off for me? And then we'll talk about them as a group. Anybody? Raise your hand. Anybody? No one? Okay, go ahead, Julia, go. What's the first one? Limit as x goes to 0 from the right. 3? What about 2?
0.
Yep. What about 3?
Discontinuous.
So the limit does not exist. Yep.
I'm sorry.
Exactly, that's perfect. 3 from the left.
And 0.
0, and then 3 from the right.
0.
And what about the limit?
And
And for limit as x goes to 3? For 6.
0.
Yeah, it's 0. If the left-hand limit is 0 and the right-hand limit is 0, the limit is 0. Done. Does the function need to be defined right there for the limit to exist? No, it does not. It does not. Very good. And then it says, where is it discontinuous? X equals
3. Oh, x equals
3 is one of them. And where else? Where else? 0. Yep. Where do you need to pick up your pencil in order to make the next part of the graph? At 0 and at 3. Does that make sense, everybody? Is that better? So just because it says sketch it at the end doesn't mean you have to. Can you do it at the beginning? Absolutely. Now the bigger question, another question is, do you know how to graph piecewise functions on your calculator? Did we do that in this class? Yeah. I think we did it a little bit, right? The key thing to remember, I'm going to put the screenshot in just of what it looks like. Plug in a function. You need the function and then the part of the domain you want to graph right there in parentheses. I'll get a shot of this. Are 1 at a... Now here's the thing, make this look a lot of different ways and still have those things hold true. Basically, can I warp that? Absolutely. Can you cross a horizontal asymptote? Yeah, you can cross any asymptote you want except for vertical. So for example, I could make it look like this if I wanted to. It could go down like that, and then it could go woo like that, right? It could, right? It could also go wee like this, right? And maybe not double back on itself, but you know, something like this. Could it do that? Sure. Absolutely. My recommendation is one at a time and keep it simple. Keep it simple. Sound good? We better with this one now? You agree?
Yeah.
Who said factor? Factor, 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 factor. You're trying to simplify, so you should always try to factor, my favorite thing. So you have the limit. Bake you cookies? No. Factor. 1 from the right. What's the numerator going to factor into? Yes. X minus 3 times x. And what's the denominator factor into? X minus 1. What cancels? Okay, so now the question is, what do you do next? You do this. This is equal to the limit as x goes to 1 from the right of x minus 3 over the limit as x goes to 1 from the right of x minus 1. What does the top become? If you go to 1 from the right of x minus 3, what does it become? Negative 2. What does this go to? If you're approaching 1 from the right, it goes to 0 because you're subtracting 1. Does it stay positive or negative along the way? Does it say positive or negative down here along the way? You're starting from the right of 1. So you're taking a number that's greater than 1 and you're subtracting 1. So it's always going to be. So this is going to 0 from the right, so it's always going to be positive. What is negative 2 divided by a really, 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 really small positive number? Negative infinity. Negative infinity. This means, what does 1 from the right mean? It means that you have a number line. Here's 1, and here's 1 from the right. You're going closer and closer to it, right? And you're subtracting 1. What happens when you subtract 1 from a number that's slightly greater than 1? Are you left with a positive or a negative number? A positive number. What is negative 2 divided by a really, 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 really small negative number? It's getting more and more negative, and it's getting bigger and bigger. Negative. Does that make sense? Always remember that you can factor. You should try to factor. You should try to factor. You should look at, oh, difference of squares. Ah, there it is. Got it, everybody? Did he? No. What's the only thing we changed on this one? It's going from the left, right? The top will still go to negative 2. The top will still go to negative 2, but the bottom is going to 0 from the left. What's a negative divided by a negative? Positive. That's where it comes from.
Does it really make a difference?
Must be greater than or equal to 0. So x squared must be greater than or equal to 9. How do you make x squared greater than or equal to 9? Either x is greater than or equal to 3, or x is less than or equal to negative 3. Exactly. If you make, then both of these things need to be true. Both this and this need to be true. So what do? You take a look at your number line if you want, which is a great way to visualize it. You have negative 3 right here filled in, going to the left, like that. And then you have positive 3 filled in, going to the right. Then you have negative root 2 and positive root 2. Well, if you're already outside here, do you have to worry about those negative and positive root 2's? No, they're already taken care of. They're not included, right? So where is this continuous? Right there. Another way to write that, the most efficient way to write this is this. The absolute value of x has to be greater than or equal to 3. Absolute value of x means distance from 0. So this says distance of x from 0 must be greater than or equal to 3. That's what it says. This is the shortest way to write it right there. Right there. What are the two most common things you can't do? No roots of negative numbers, no even roots of negative numbers because it makes it imaginary, and no dividing by 0. Also, you can't take the logarithm of a negative number. That's the only other thing you really have to worry about. But all the trig functions, like sine and cosine, what's the domain of sine and cosine? All real numbers. What about the domain of tangent? What's the domain of tangent?